The familiar world of near space consists of the blazing sun and 8 different planets, after the non-conforming Pluto was removed from the list. This information is instilled in children from their school days, overlooking some important details, such as the existence of dwarf planets between the orbits of the gas giants. Among them, one stands out in particular, a little one named after the Roman goddess of agriculture, Ceres. The planet is a small sphere, measuring 975 by 909 kilometers, orbiting between Mars and Jupiter in the asteroid belt. The surface area of Ceres can be roughly compared to that of Yakutia, with Yakutia being larger. The idea of colonizing the small planet Ceres has been discussed more than once in certain circles. It could be used as an intermediate base for building orbital colonies or for interplanetary travel. Why do scientists consider this possibility? Could it be that this tiny celestial body actually has conditions suitable for terraforming? And is it really the water world we've been searching for over the past decades? Let's try to figure it out. People spoke more confidently about colonizing Ceres after the Dawn probe data was released. National Aeronautics and Space Administration launched it back in 2007. The purpose of the probe was to study the asteroid Vesta and Ceres, which are classified as minor planets, but are still the largest objects in the main asteroid belt. The spacecraft was intended to study the true shape and exact size of the celestial bodies, and to determine the details of their terrain in order to create relatively detailed maps. Dawn successfully accomplished its mission. Arriving in orbit around Ceres, which is located 418 million kilometers from the Sun, in April 2015, it remained there until the second half of 2018, until it completely ran out of fuel. From that moment, the 11-year mission was considered fully completed. Was it possible to accomplish all the tasks set during this time? Absolutely. What did the orbital probe discover on the surface of Ceres? And what conclusions did astronomers draw after processing the obtained data? Based on tens of thousands of photos, the following cold traps were discovered on Ceres. This discovery by the probe can definitely be considered an argument in favor of the potential water world that was mentioned at the beginning of the video. Natural traps on the small planet look as follows. Impact craters, located closer to the poles, contain regions where sunlight never reaches the surface. The temperature at the bottom of the huge craters does not rise above -150 degrees Celsius. Scientists estimate that's exactly where water ice is stored, like in a refrigerator. According to calculations, the area of the discovered traps on Ceres is 1,800 square kilometers. The fact is that the planet's gravity allows water molecules to remain on its surface, so the presence of ice accumulations at the bottom of numerous craters is quite logical. The icy mountain Ahuna is the closest cryovolcano to our star, and the only one on Ceres. The mountain, 4.5 kilometers high, is made of ice and is also covered with longitudinal grooves, presumably left by boulders rolling down its slopes. It is a truncated cone with an elliptical base measuring 13 by 21 kilometers. The block of ice was formed as a result of multiple cryovolcanic eruptions. Instead of lava, ammonia-methane liquid flows from the volcano's crater, spreading and shooting hundreds of kilometers upward. The specific structure of Ahuna confirms the presence of significant reserves of liquid salty water beneath Ceres' surface. Mysterious white spots. A distinctive feature of Ceres' surface is a bright snow-white area, the origin of which scientists have been debating for years. It is located at the bottom of the 6-kilometer deep Occator crater discovered by the Dawn probe. Spectrometer analysis showed that these spots consist of soda crystals, But where did they come from at the bottom of this huge pit? Astronomers have only one theory. The evaporation of liquid water was definitely involved here. Most likely, the meteorite impact that formed the crater melted water beneath the planet's surface, causing the liquid to disappear and leaving behind a carbonate deposit. In the mornings, a whitish mist rises over Akator, filling the crater about halfway. The spots were named after the Roman festivals Facula, Cerealia, and Venalia. In addition to the three bright features, Ceres has a relatively smooth surface of its icy mantle, which is covered in places by impact craters. The temperature on the dwarf planet ranges from -106 to -33. The duration of a year is 4.6 degrees. Dozens of craters have been discovered on the planet, and 17 of them have been given proper names, all named after deities of agriculture and fertility. Deposits of rocks rich in organic matter have also been found. Discussing the data obtained during the 2-year mission, scientists agree on one thing. Ceres is a celestial body with abundant water resources, and not only in the form of ice caps or natural freezers. Experts claim that since the planet is made up of 25% water, the natural reserves of H2O on Ceres may exceed all the fresh water resources available to humans on Earth. They are likely stored in the celestial body's mantle. Here it's worth returning to the topic of colonization. It is believed that all these natural resources concentrated in a 90-kilometer layer of ice could provide invaluable service to astronauts or settlers. Ceres' low gravity is also considered an advantage, since transportation from the planet's surface would become very energy efficient. An industrial facility to extract asteroid resources can be built on a small celestial body. The fact that the planet contains about 200 million cubic kilometers of water in the form of ice gives hope for its transformation into oxygen and hydrogen systems. The latter will be needed for fuel production. In addition, it also makes sense to develop the mining industry on Ceres itself. However, most likely, humanity's first experience of colonization will take place on the Moon and Mars, and only then will it be Ceres' turn. Despite its benefits, the dwarf planet still poses risks to humans. Here are a few drawbacks that will have to be taken into account. Ceres has no magnetic field, which will inevitably affect human health. There is a total lack of sunlight and a thin atmospheric layer, and Ceres is also extremely vulnerable to asteroid bombardments. Despite all of the above, the dwarf planet is a tempting target that we will definitely reach sooner or later. We are constantly being frightened by all kinds of cataclysms, and it's claimed that Earth, as the cradle of humanity, is literally on its last legs. But we suggest not to panic and instead pay attention to the other planets of the solar system. Besides ours, there are 7 more, and credit must be given to Earth's astronomers for that. All this time, they haven't been sitting idly by. They've been actively trying to study our neighboring planets using modern equipment and probes. Eventually, they even reached the distant and hazy Uranus. But you'll say that's a gas giant without a solid surface to land on, and besides, it's completely frozen. So what? As the hero of a famous movie once said, there are no obstacles for patriots. Let's take a look at Uranus through the eyes of Voyager 2, the only probe to have visited the planet's vicinity. So, what is this bluish, constantly lying on its side, frozen gas giant like? This world is as different from ours as a basketball is from a sea urchin. Uranus is very cold. If you tried to live there, you would have to endure temperatures of -224 degrees Celsius, and you would also have to get used to never having solid ground under your feet. It would be like living among the clouds. The states of matter here don't have clear boundaries. gas gradually transforms into liquid, and then the liquid, in turn, becomes something similar to a solid. On the planet, the smell of hydrogen sulfide and ammonia is everywhere, like rotten eggs and urine. Uranus is 60 times larger than Earth. Here, winds blow at speeds of 824 km/h, and thunderstorms flash almost constantly, which could outdo all the storms on Earth combined. This place, of course, is not for everyone. Add to that a 42-year-long winter and other seasons that last just as long. No wonder the planet was ignored for so long, right? But in 1986, a National Aeronautics and Space Administration probe called Voyager 2 did fly by Uranus. And although the visit was just a flyby and the encounter was quite brief, the probe managed to photograph the Uranus system along with its rings and closest moons. False color of Uranus? The outer ring of Uranus? Miranda Uranus moon. Colors of Uranus. True color on the left and false color views of Uranus. January 17, 1986. Distance 5.7 million miles. 3 moons discovered by Voyager 2. 1986 U1, 1986 U3, and 1986 U4. January 18th, 1986, distance 4.8 million miles. Aberon. The best image of Aberon shows craters and a large peak on the lower limb of the moon. January 24, 1986, distance 410,000 miles. The ring system, viewed from behind, shows a continuous distribution of small particles throughout the entire ring system. January 24, 1986, Aberon, range 147,000 miles. When project manager Edward Stone summed up the interim results of the mission, he said that no probe had ever seen a more unusual system. Scientists were especially amazed by the so-called magnetic tail discovered by Voyager 2 at the ice giant, as well as the landscapes of Miranda, one of the planet's closest moons, which were clearly visible in the photos sent by the probe. On the Uranian moon, for unknown reasons, there was an incredible mixture of diverse worlds, Martian valleys and channels, the deepest Mercurian faults, Ganymede's grooves, and monstrous lunar craters. At least 10 types of terrain have come together here. Also, among other things, the spacecraft incidentally analyzed Uranus's atmosphere, discovered 2 new rings, and found 10 previously unknown moons. As they say, everything it managed to do, but why hasn't any other spacecraft visited the giant since then? The unfortunate situation happened for the same reason as with distant Neptune. The location being studied is incredibly far away. First of all, with the current level of technology, a flight to Uranus would take at least 15 years and would involve multiple gravity assists. Secondly, no solar panel will work at a distance of 3 billion kilometers. After all, Uranus orbits 20 times farther from the Sun than Earth does, which means we would have to use a nuclear power source, which is much more complicated and expensive. The next problem is adequate data transmission, because there is no point in sending an expensive and lengthy expedition that will send back photos to Earth with last century's quality. That's why it's quite logical to ask about equipping the Uranian station with a huge antenna and building a gigantic receiver on Earth. And the last hurdle is the team of specialists supervising the flight. After all, during this time, the staff could easily thin out, and we haven't even started discussing the equipment for the probe yet. The task ahead is very difficult, but achievable. Now, the main question is, why are these incredible efforts necessary, besides understanding the principles of the formation of ice giants and their systems? But there are reasons, and they are significant. The extraction of valuable resources, and secondly, the possible colonization of the planet. Yes, you heard right. A celestial body without a surface can be settled by human colonies. So let's start with factories for extracting helium-3, an element abundantly found in Uranus's atmosphere. How can this plan be carried out? First of all, a base should be built on one of the moons. Then an army of remotely controlled robots needs to be sent to Uranus to pump atmospheric streams, filter them, run them through centrifuges, and liquefy them. To carry out the process, most likely a drifting base will be created powered by thermonuclear fuel and located directly in Uranus's atmosphere. Considering the escape velocity on Uranus, which is the lowest among all the giants, transporting cargo will surely not be problematic. But no matter how many robots we use, it's hardly possible to set up and launch such production without involving people. Therefore, the question of establishing colonies naturally arises. But where can this idea be implemented besides on satellites? Since Uranus doesn't have a surface, it's simply in the atmosphere. For example, if you fill huge balloons with hydrogen, they could keep entire cities afloat, and the gravity here would be similar to Earth's. To carry out even a part of Napoleon's ambitious plans, it's necessary to launch at least one more mission in this direction to start with. National Aeronautics and Space Administration has discussed this project for a long time, but high costs and delays keep pushing it back. Meanwhile, the next launch window for a flight to Uranus is between 2030 and 2034. In these conditions, travel time will be about 12 years. But if everything that's planned comes true, the world can expect a whole bunch of sensations. This can be said for sure, because the Uranus system is one of the least explored locations. The objects discussed in this video, fortunately, are very far from Earth. Otherwise, everything we're used to seeing around us would never have existed. Why? It's very simple. This cosmic monster would have simply devoured or burned everything within millions of kilometers, callers. Before I name the mysterious object, take a look at the photo. In the picture, it's placed among other celestial bodies and looks almost indistinguishable from them, even though it's immeasurably far away. Let's reveal the intrigue further. Today we're discussing the amazing, little-studied, and sometimes downright frightening quasars. These objects are shown next to others, and for a long time after their discovery, observers couldn't distinguish quasars from ordinary stars for good reason. A lot of years have passed since then, so it's logical to ask, what do we now know about quasi-stellar radio sources? Let's immediately dispel a common myth. Not all quasars emit in the radio range. Therefore, the second part of the established name is incorrect. So, let's get back to the vastness of space. The name of the first quasar discovered by astronomers is 3C48. The discovery happened when Alan Sandage and Thomas Matthews were conducting a radio survey of a certain part of the sky, and that's when they saw a strange object. In 1963, 5 such points had already been found, and now there are thousands of them. The most distant quasar from us, whose name is quite difficult for me to pronounce, is located at the edge of the observable universe at a distance of 13 billion light-years, while the closest one, 3C273, is about 2 billion light-years away. What is so remarkable about these objects? They have many features that cannot be explained from the perspective of orthodox science. Their nature is unclear. First, we need to find out what these could be, and how and where the monsters whose light we are now observing were born. There are no reliable answers to these questions yet, only guesses and hypotheses. For example, some astronomers are sure that quasars are nothing more than an active galactic nucleus, at the center of which is a supermassive black hole. We are believed to witness a brief yet painful stage of galaxy formation through telescopes. That is why a limited location emits such an intense light. There is another original theory. Quasars are superstars that intensely burn their own hydrogen, which is why the process is accompanied by massive releases of energy and light. But not everything is smooth in this hypothesis. Such an object, if it existed, would have to weigh as much as 1 billion suns, which is basically impossible. A body that massive cannot remain in stable equilibrium for long. Therefore, scientists continue to be puzzled, and the source of the quasar's inexhaustible energy has not yet been discovered. By the way, about the source that feeds these intragalactic monsters. After long debates, astrophysicists have concluded that a thermonuclear nature, like that of ordinary stars, is completely ruled out, since the colossal energy emissions and unreal luminosity would be impossible in that case. Most likely, quasars are powered by the energy of a gravitational field, meaning the same supermassive black holes. Quasars' unreal glow is the reason they're often called the beacons of the universe. This is primarily indicated by the fact that, no matter how far away they are, these objects are clearly visible through ordinary telescopes. Let me give you a small analogy. If you bring a lit flashlight close to your face, it will subjectively seem brighter than the sun. But if you place the flashlight and a star side by side, the star's glow will be incomparably more powerful. This simple example helps to understand the meaning of the concept of absolute magnitude. This value for the sun is only 4.8, while for one of the first discovered quasars, it is minus 26.7. That's 4 trillion times brighter than our star. And the most dazzling object ever observed has an absolutely extreme absolute magnitude of minus 31.4. If we talk about the amount of energy emitted by the sun and a quasi-stellar object in the same unit of time, the difference is 10 trillion times. Quasar radiation can surpass the total brightness of all a galaxy's stars, and millions exist. If such an object were relatively close to us, say 30 light-years away, it would shine as brightly as the sun. A single quasar's energy could power Earth for billions of years. Among other things, the monstrous jets of quasars deserve attention. Bursts of energy whose streams extend for millions of light years. All of this, according to astronomers, is the work of black holes, rapidly and greedily devouring matter that falls into their insatiable funnels. The heating in such regions reaches billions of kelvins, and it's extremely difficult to imagine this kind of hell. Super escape velocity. How can we determine the distance to a quasar? For this, the notorious Doppler effect is called upon to help. With its use, we can determine the degree of redshift coming from these cosmic monsters, and as a result, it turns out that they are rapidly moving away from us at tremendous speeds. For example, Quasar 3 C196 is receding at an incredible speed of 200,000 kilometers per second, which is 2/3 the speed of light. For comparison, the maximum speed of galaxies is only tens of thousands of kilometers per second. Variable nature. The most inexplicable fact is the variable luminosity of quasars. The fact is that this indicator varies not only throughout the year, but sometimes even up to 25 times an hour. What causes such frequent fluctuations is an absolute mystery. From this phenomenon, we can conclude the size of quasars. It becomes obvious that they can't be too large. Otherwise, the fluctuations in luminosity would reach us not simultaneously, but in steps. So we are dealing with relatively compact objects that, at the same time, outshine entire galaxies with their light. Scientists have pondered these mysteries for decades, but one thing is relatively clear. If we were to teleport right now to the place where the quasar is supposedly located, we would remain completely unharmed. Why? Shouldn't the monster have instantly incinerated us? But most likely, the alien astronaut would be disappointed. This location has probably been empty for a very long time, since the light emitted by the quasar traveled to us much longer than the object's lifetime. Quasi-stellar monsters are products of the early universe, so many of them have already gone dark. What the situation is really like is unknown, but for now people see the blinding light of quasars. The journey into the past never ends, since we study the oldest objects in the macrocosm. Take a look into past eras together with the Hubble channel, and don't forget to hit that cherished like button, as well as the subscribe button with the bell, so you don't miss notifications about new stories. So much awaits us. Let's go.